We just received a letter from the Blackstone Watershed Relay people congratulating us on the work we've done and giving us new challenges. The blue team's challenge is to learn about the history of transportation in, on, over, and around the river. Some of the team will focus on the earliest transportation, some on bridges, and some on the Blackstone Canal. The green team's challenge is to investigate aquatic plants. Aquatic plants are plants that live in the water.
Look at this place.
Oh my god, it's so cool. I love it here.
What is that?
Whoa, look at that. Oh my god, we both saw it. So cool.
I think we're here on the West River.
Wait, what are we doing?
We're looking for the 3 types of water plants. Remember, submerged, emergent, and floating leaf.
Let's go see what's on the other side of that bridge.
Okay.
Look at that plant.
It's huge.
I did a research project on them last year. They're called cattails.
Why are they called cattails?
Do you see the big puffy thing on top?
Yeah.
Well, it looks kind of like a cat's tail.
Have humans ever used cattails for anything? They look useful.
Hold on, let me check my book. Native Americans ground the cattail stems into meal. The flowers were eaten like corn on the cob, and the pollen used for baking. Cattail leaves were great weaving material for mats, baskets, and chair seats. The other impressive thing is that a cattail stalk holds about 220,000 seeds.
These cattails sound really interesting. Let's bring one back to school and look at it under the microscope.
Sounds great.
Man, it's a lot noisier here next to the road.
Whoa, look at those big green plants on top of the water. They must be floating leaf plants.
Remember, those are water lilies. We saw them while we were canoeing Lake Wildwood.
I wonder how water lilies adapted to river and marsh life.
Water lilies adapt to river and marsh life by having the leaves flat on the water so the current doesn't rip the leaves.
That's cool.
I was thinking about what my Aunt Matilda told me about the adaptations of aquatic plants. Now it makes sense.
What did she tell you?
Well, she told me how aquatic plants are like whales.
Like whales?
Yeah, like whales. All life started out and evolved in water. After millions and millions of years, water animals evolved into amphibians, like salamanders, so that they could live on both land and in the water. After I talked with my Aunt Matilda, I made a sketch. After amphibians, reptiles and mammals evolved. They could live on land, but were still dependent on water to drink.
You mean like us? We live on land and need water?
Yeah, whales' ancestors were also mammals, but they evolved so that they could live in the water to take advantage of the unused food resources.
I still don't get the connection to aquatic plants.
Oh, I made another sketch. Aquatic plants also started out in water. After time, they evolved so that they could live on land, and then evolved again so that they could live in the water again.
I think we should head back to school and see if we can find out more about aquatic plants and how they adapt.
Plants turn out to be more interesting than I thought they were. I found out something unusual about water lilies. I made these models to help illustrate it. This model shows how the water lily leaf is on the surface of the water as the stem goes down through the water into the ground to where the roots are. This other model, which is an enlargement of a small part of the water lily leaf, these are the stomata that let air in and out of the leaf. These are the guard cells that make the holes open and close. The unusual thing about water lilies is that they have the stomata on the tops of their leaves instead of the bottoms.
Water lilies and other aquatic plants don't usually have problems getting enough water. They have problems getting enough air. So, if you have leaves that float on top of the water, having stomata on the top of the leaf is a good adaptation.
Yep.
You know how it's hard for a submerged plant to get oxygen and carbon dioxide because the leaves aren't sticking out of the water into the air.
Yeah, submerged means completely underwater.
The key to getting oxygen and carbon dioxide is the leaves. The leaves absorb the oxygen and carbon dioxide from the water as it's moving past them.
So the leaves kind of act like sponges for the oxygen and carbon dioxide that's dissolved in the water.
Then why don't the plants have bigger leaves? Wouldn't they be able to absorb more oxygen?
Actually, Joe, bigger leaves don't help. See, if the leaf gets too big, then it slows down the water that's moving past the leaf. That reduces the amount of water that will move past the leaf.
How do you keep the leaf from getting too big?
It's really cool. Submerged plants use something called apoptosis.
Apoptosis? That reminds me of hippos.
It may remind you of hippos, but it doesn't work like that. Apoptosis is the programmed death of certain cells so that the leaf doesn't get too big.
The plant kills its own cells?
Sounds crazy, but it's true. And that's what helps the plant get the oxygen and carbon dioxide it needs.
Cattails live on the edges of ponds and rivers, or in marshes, wet places, so the roots are in soil that's completely filled up with water with no room for air. But the roots need oxygen too, so cattails use something called a parenchyma to get air down to their roots.
What are anenchyma, parencia, whatever you said?
Parenchyma are small air spaces in the stalk of the cattail. Air can travel through those spaces from the leaves all the way down the stem to the root zone. Here, have a look. I have a piece of the cattail stalk here for you guys to see.
Whoa, this is really cool looking. I can see the air spaces clearly. Do they travel all the way down the stalk?
Yes, the parenchyma are in the center of the stalk. There are air spaces all over the middle.
So, all three of these aquatic plants have adapted to living in water by having special arrangements for getting air.
Sort of like the way that the whales adapted to breathing through a blowhole when they evolved to live in water.
Just like my Aunt Matilda said.
Our challenge was to learn about aquatic plants on the West River and share the knowledge we learned.
So first of all, aquatic plants are plants that live in water.
To learn more about aquatic plants on the West River, we took a trip down the West River to see what kinds of plants live there. Well, we got to a part of the river where it was really hard to paddle.
Yeah, and when we lifted up the paddle, we found it was covered with these things. They were obviously aquatic plants, but they had taken over the whole section of the river. When we got back to Bobby's house, I went on the internet to try and find out what they were, and Bobby and Sarah looked in the field guides.
It turns out that they were water chestnuts, which are invasive, non-native aquatic plants.
Invasive means that they take over wherever they go, making it almost impossible for other kinds of plants to live there. Non-native means that they come from a different ecosystem, which is bad because they usually have no natural predators. In other words, it means that nobody in their new environment wants to eat them. So that means that invasive, non-native aquatic plants are really bad news. Sometimes people forget that native plants are really good in their habitat. They provide food, oxygen, shelter, and help prevent erosion, and invasives interfere with those functions.
Invasives really take over, like in that part of the West River that we saw. When we saw it, we almost couldn't believe that it was happening.
Water chestnuts are a nasty plant. They're really well adapted to take over. They have spiky seeds that animals can't eat and can last in the mud for up to 9 years. They have air bladders in the stems which allow them to float on the surface of the water and get plenty of light. This can cut off light for submerged plants.
Plus, there's only 2 ways to get rid of them. One is to pick them by hand, and the other is to use a harvester.
The Blackstone Watershed Association decided to get a grant for a mechanical harvester, but the harvester doesn't fit in some places along the West River.
Wow, these are really nasty looking seeds. If you don't pick water chestnuts by hand in spring before they grow these seeds, then they can fall out and start growing again the next season.
And what about purple loosestrife?
Purple loosestrife has been around for 200 years. It grows over 4 feet tall, and it's really common. It comes in pinks and, of course, purple. They have beautiful flowers, and each plant can produce 1 to 3 million seeds every year. That means it can spread really quickly. Well, you might think, what's wrong with that? I mean, they look pretty neat. But they crowd out cattails. And if they crowd out cattails, that means the animals that depend on cattails have to leave. For example, muskrats depend on cattails for food and as building materials for their lodges. If the cattail leaves the area, then muskrats have to leave or die.
A lot of people see a pretty plant, like purple loosestrife, pick it and take it home, and accidentally drop it in a different waterway. Well, that's a big mistake.
So let me get this straight. Some people think an invasive is pretty until it is taken over.
Yeah, and that can be pretty bad news for the environment and the community.
I know, some people get so mad when it's hot and they can't swim because the water's choked with invasives.
Yeah, and that's not all. Invasives can cost a lot to control, and that's why the Weed Watchers program started.
Weed Watchers, what's that?
Weed Watchers is a volunteer organization that's working hard to protect Massachusetts water bodies. They have many programs like boat ramp monitors and...
What's a boat ramp monitor?
Boat ramp monitors are people who check boats coming in and going out of infested waters.
It's important if you go into infested waters that you check for any hitchhikers.
What are hitchhikers?
Plants and animals that get in or on your boat.
Weed Watchers trains people to look for invasives and eliminate them in a way that's not really expensive.
Cool. Where can people learn more about Weed Watchers?
Yeah, there might be people watching who want to learn more.
Well, you can go to www.mass.gov/lakesandponds.com, and when you get there, click on Weed Watchers.
That studio shoot was a lot of fun.
Yeah, you know how the blue team was working on transportation in the Blackstone Valley?
You mean the canals and the bridges in Millville and the Native American Indians?
Yeah. And as they were telling us about it, I thought that maybe the faster that humans travel, the faster that invasive species can travel with us.
Also, the way humans have built so many devices and inventions, it sort of reminds me of the adaptations of plants.
But humans make stuff and change their environment instead of just adapting to it like plants do. And you can really see that in the Blackstone Valley.
Hi, Robert.
Oh, hi. Wow, now I really understand why they needed a canal.
Why?
Because the roads were muddy and bumpy and slow. It cost as much to ship goods from Worcester to Providence as it did to ship from England all the way over the sea to Providence.
So basically, it was cheaper to send goods by water than by land?
Exactly, that's why they built a canal.
Hey, let's go outside and look around the park. It looked pretty neat.
Cool, okay.
Yeah.
Hey guys, that's a map that I was telling you about.
Oh, wow. Oh, this is a perfect example of what I was telling you up there. Here's the Massachusetts and Rhode Island border, and here's Worcester, and here's Providence. It looks like we're right around here, and there's Boston. And this is a perfect example of what I was saying because Worcester's here, and with connections to Providence here, Boston's all alone over here, and, left out of the deal.
My name is Val, park interpreter here along the Blackstone River and Canal. Can I help you with anything?
We're from Touchstone Community School in Grafton. I'm Robert, and this is Melanie and Kale.
Oh, you're working on one of those challenges on the watershed. Would you like to take a walk along the towpath? Well, the river looks good for canoeing, but can you imagine a large boat being able to be controlled with that current?
How did the canal boats get up or down steep slopes in the canal? I mean, the canal dropped the same amount as the river did.
That's right. And back at the visitor center, we have a model of a canal lock. And we can demonstrate how those canal boats can travel on flat water, be lifted 10 feet, and travel on flat water from Providence to Worcester. From Worcester to Providence, the canal boats would travel down the Blackstone, and through a series of locks, lift locks, they would be able to descend at 450 feet. With our model, which we do see a boat, and a mighty fine boat it is, with the water level the same as the basin above and the water in the chamber. Our boat can navigate right into our lock. Our lock tender, who's attending to this lock, would close up the gates, the upper gates. Now, to lower our boat or to raise it, we would need to, through gravity feed, adjust the water level. And through a wicket gate, we can open a valve to drain the water. In a real lock on the canal, it would be a 4-minute process to drain the lock chamber. I think the lock chamber is drained. The tender and some of the crew members would open the lower gate and allow the boat to continue on after it has dropped 10 feet and continue its journey downstream.
I noticed you had a painting of a canal boat over there.
Let's go take a look at that. It's an artist's rendition showing horses pulling a packet boat, which would carry passengers as well as some freight.
I noticed in the exhibit that the canal was only operating for about 20 years.
Well, that is true. It was built near the end of the canal era on the dawn of the railroad era of transportation. And the canal was eventually replaced, functionally as well as physically, by a railroad between Providence and Worcester.
But all these ways of transportation started with the river in a way. I mean, first, people traveled along the river. Then, they borrowed water from the river to make the canal. And then we found even faster ways of traveling. But the cities at the top and bottom of the river are still important.
So where are we going again?
We're going to Millville, where I live, because there's an important bridge there.
Really?
Yeah, there's this one bridge over the Blackstone River, and it was under construction for a while, so it was only a pedestrian bridge, so you couldn't drive over it, and we had to drive 12 miles just to cross the river. There's a lot of historical evidence there. My mom gave me this brochure.